so, who had something you missed on your quiz that you don't get it? You don't understand why you missed it, and you're not sure how you would get it right, David?
It's like a word problem.
Yep, go ahead and read it to me.
How tall is the building if...
Okay, stop. How tall is a building? So I'm starting with this, okay?
If I am standing 200 feet from it.
If I am 200 feet, here I am, right here, this is me. I am 200 feet from the building.
My angle of elevation to the top is 11 degrees.
Okay, does that picture make sense to you?
Yeah.
Okay, so what function am I going to use?
I said cosine.
Okay, what's cosine? So katoa, what's cosine? Adjacent over hypotenuse.
Yeah.
What have we got here?
We want the opposite over adjacent.
There you go. So that is tangent. So yeah, tan 11 equals x over 200. So x equals 200 tan 11 would be your equation. You didn't have a calculator, so you stopped there.
Okay.
Okay, Jason?
Number 2, cotangent of -1 times √3/3.
Okay, now, part of the issue is he didn't say that right. Now, good thing, this isn't an oral quiz, all right? So you don't have to talk it out. But if you know what this means, then exactly, you are looking for the angle whose cotangent is √3/3. Which means, I don't have rules for this. These are the ones that have rules. Remember quadrants, you're only in certain places. I don't have rules for that. I have rules for this. So if the cotangent is √3/3, then the tangent would be 3/√3. Right, they're reciprocals of each other. And I don't like the way that looks, so I'm going to go ahead and clean that up. Oh gosh, that's really just √3/1. So I have an angle out there whose tangent is √3/1. Well, which quadrant will it be in? One or 4, positive being 1. Tangent's √3, that means the reference angle is 60. So the answer is 60 degrees. Okay? Emily?
Find a negative coterminal angle in radians for pi/7.
Pi/7, a negative, we want a negative coterminal angle. Remember that to find any coterminal angle, we either add or subtract. Ike, what are you doing back there? Yeah, let's unchill. To find coterminal angles, we either add or subtract revolutions. I am in radians, so I am going to be adding or subtracting 2 pi. If I were in degrees, I would add or subtract 360. So it said stipulated negative, so I'm obviously going to subtract pi/7 minus 2 pi/1. Those are 2 fractions. I need to subtract them, so I'll get a common denominator. So I have pi minus 14 pi, which is negative 13 pi over 7. Brenton?
Can we go secant 3 pi/4?
Secant 3 pi, find the secant of 3 pi/4. That is the opposite kind of question than Jason asked. In Jason's question, I knew the ratio, I knew the fraction, and I had to work backwards and find the angle. You know the angle. You're just going to figure out what the fraction is. Well, it's a secant, which is reciprocal of cosine. So the fraction is going to be hypotenuse over adjacent. So now I just got to figure out what that angle looks like. 3 pi/4, pi is 180, 45, 135. So I'm finding the secant of 135 degrees. which means that the reference angle here is 45. So it's 1 root 2, and that one is negative. Remember, if you're not in quadrant 1, something's negative. Now with the secant is hypotenuse over adjacent, so that's going to be negative root 2 over 1 or negative root 2.
I put the angle.
Okay, it's very common because that is a step of the problem, but that is not what you were asked for. You were asked for the secant. All right, who else? On the quiz, anything else? Max?
The question says, how far from the base of a 19 feet tall tree?
Okay, stop right there. How far from the base of a 19-foot tall tree? So that's the setup so far. Here's the base of the 19-foot tree, and it said how far is something. All right, what's the rest of it?
Is Ross standing if his angle of elevation to the top of the tree is 18 degrees?
There's your picture. Would everybody agree? Read the question one more time because not everybody has that paper.
How far from the base of a 19 feet tall tree is Ross standing if his angle of elevation to the top of the tree is 18 degrees?
Everybody okay with that picture?
Yeah.
What function is that? What trigonometry am I going to use? Tangent. So the tangent of 18 equals 19 over x. My job is to solve for x, so I'll multiply it over and then divide. So x equals 19 divided by tan 18. That's what I would type into my calculator.
So that's what you meant by right equation over.
Yeah, wouldn't it just be tan 18 equals 19 over x?
I believe, doesn't it say x equals?
Yeah.
Yeah, so what does x equal?
Oh, okay.
If it was a calculator problem, you'd put it in degrees.
You would be set in degrees, because that is an 18-degree angle. Cassie's your hand up?
No,
Grace.
Did we get a bonus point because everyone was here that day?
Did I, somebody check Power School and see if I put in one more point that's on your paper?
You only didn't do
Yeah.
Yeah, I think I put it in when I put it in the grade book. But double check that and let me know. Yes, you should have. All right. So everything else is good? No issues. Everybody else knows everything on there. Okay, then what I want you to do now is to get out your big packet.
The one you just gave us?
No, oh no, the one I just gave you, that's for chapter 5. We're putting that away. I just wanted everybody to have it before we all take off and go.
Which one are you gonna work on?
I think we are going to work on page 5. I don't think we've done page 5 yet.
Is that Precal practice 4-1-2-1-3?
Yes. Number 2.
Find the 6 trig values.
Yep.
Is that one of our biggies?
Pardon me?
Is that one of our?
No, your homeworks are on the review sheets.
Oh, okay.
Okay? And those are all on video. So between the 3 different classes, I've done a review sheet in each class. So everybody has one done already, and then you're kind of working on the other ones on your own. Our last review day, which is tomorrow, you said we meet tomorrow, I will take whatever questions you've encountered. So if you started those review sheets and you have issues, right now, if you started them and have issues, feel free to ask them. Otherwise, I'm just picking problems to do. So if you have a particular problem, now would be the time, or tomorrow would be the time to say something about that. Okay? I think before we start this sheet, we'll do a couple of sketches to make sure you're okay with that, because you will have to graph a couple of things on the test. Without your calculator, you'll have to graph them. So is that okay if before we start this sheet, we just do a couple of sketches? Let's do a cosine. So that will pretty much cover everything, and then we'll do a tangent.
Is it gonna be on the,
So we're gonna graph these two. So before we do that, let's list the amplitude, period, phase shift, vertical shift, and frequency for both of them. And then we'll sketch it. Okay, so let's start here with our cosine. Let's fill in. What can we fill in? We know the amplitude is 3. Now, what that means is, when I get ready to sketch this, I'm going to go up 3 and down 3 when I sketch it. It's been vertically stretched. All right, what else can you tell me?
The period is 8 pi.
The period is 2 pi divided by a fourth, which is indeed 8 pi, which means that when I sketch this thing, it's a cosine, so it looks like this. From beginning to end is 8 pi for this particular curve. All right, what else can you tell me?
There is that the phase shift inside?
Phase shift is your horizontal shift. That's what's attached to x, added or subtracted. So we are going to start pi over 5 to the right. So this is pi over 8, I'm sorry, pi over 8 to the right.
Do you need to
So my cosine curve is going to look like this. It's going to start at pi over 8, top of the hill is going to be at pi over 8, and then it's going to end at the top of the next hill. That's what cosines do, positive cosines.
This one?
Yes.
You wouldn't need to multiply pi over 8 times the 1/4 for the phase shift.
No. That affects the period. This is your phase shift right here. Whatever is added or subtracted to x.
Okay.
Okay? Once that period's been dealt with, okay, it's dealt with. Everything else is just what it is. Vertical shift? Up 1. So I didn't do that yet, but when I'm done here, my last step, I'm going to take this picture and I'm going to lift it up 1. So everything's going to go up 1 unit. And what's my frequency?
1/4 over 2 pi.
Oh, let's just reciprocal this.
Oh, 1 over 8
So that would be 1 over 8 pi. Okay? All right, now let's finish up this graph. Let's label some stuff. I think you'll be able to figure out where the curve ends.
8 pi plus pi
You
over 8.
know it starts at 1/8, and the distance is 8 pi. It starts at 1/8 pi and travels 8 pi. So Brenton says this would just be 8 pi plus 1/8 pi, which would be 8 and an 1/8, or 65/8. 1/8 plus 8 is 8 and an 1/8, which is 65/8. Now, how about this point? This is the middle value, the midpoint. What is halfway between 1 and 65? 33. We add and divide by 2, so it's 33. Then we need halfway between 1 and 33. 17. And then halfway between 33 and 65. 49.
So you add 2 numbers between them together and then divide by 2.
Average. Midpoint is average, yes.
Why'd you put to the floor?
What?
Why'd you put 17 pi over?
I have no idea. So I could just totally mess with your mind, Brenton. Okay, now I gotta pick it up. I haven't done that yet. So I need to pick it up. So every one of those points I just labeled is gonna come up 1 unit. So the purple thing is actually the answer. The purple is the final answer. Michael?
So for your final answer for amplitude, would it be 4 or 3?
No, the amplitude is still 3.
Okay.
Because while the curve goes up to 4, it still only goes down, now it only goes down to -2. So essentially what you've done is picked your axis up. Now it's oscillating back and forth across 1. It's still going up 3 and down 3. Alrighty?
The frequency doesn't affect the picture, right?
Nope.
Now for tangent, is there no frequency then? If there's no amplitude? Or wait, no, the period, you have a period.
Everything's gonna have a frequency, but you're right, the tangent has no amplitude. Because you know what a tangent curve looks like.
That's what I was thinking.
A tangent curve has asymptotes at -pi/2 and +pi/2 and goes up. So that's your normal picture. That's what's in the back of my mind. But I made some changes. What have I changed here? What about period?
2/3.
Be careful. The period of the tangent is pi. So it's pi divided by 3. When we do sines and cosines, the standard period's 2 pi. So I do 2 pi divided by the coefficient. But with a tangent, the normal period is only pi. So everything starts with pi and then gets changed. So this one is pi/3. Alright, that's a difference between the sine and the cosine and the tangent. Alright, I have no phase shift, no vertical shift, 3/pi. Now I'm going to graph my picture. Now, since I have no shifts going on, it's going to look just like this. It's going to have an asymptote here and an asymptote here, and it's going to go through and look just like that. The only difference is, now, instead of this distance being pi, this distance is now only pi/3. So that means I have to go forward and backward so that the total is pi/3. You see what I'm saying? So how much would I go forward and backward if the total distance has to be pi/3? Pi/6. There we are. Because if you go forward a sixth and backward a sixth, you've gone 2/6, which is a third.
So is it normal just the period divided by 2 is what it's on each side?
Yes, as long as you haven't shifted. I mean, that's the distance you're going to go on each side. Exactly. Yes, that will always be the distance you go. Alrighty? Alright, you want to do a couple more of those? You want to go on and do some more review? Review? Alrighty, here we are. We're on page 5. Nothing special about these problems, but they are from a long time ago. These were things we covered before Christmas. So. We want to find the 6 trig values, so that means we want to find sine, cosine, tangent, and cosecant, secant, and cotangent. And we know the secant is 13/10, which of course means the cosine is 10/13. And the sine is a positive number. Now, believe it or not, what you're being told is which quadrant to draw your picture. You are being told the quadrant. Now, why is that? How is that? Well, we already know that the cosine is positive. Then they also just add that little note, the sine is positive. Now remember, cosine is x, So this is telling me x is positive. Sine is y, and they're telling me y is positive. Well, if x and y are both positive, where will I be?
The first.
I'm in quadrant 1. That's the only place it can happen that I have a positive x and a positive y. So my cosine's 10/13, which means my other side would be square root of 69. So now I can fill in everything. The sine is root 69 over 13. So the cosecant is 13 over root 69. The tangent is root 69 over 10, so the cotangent is 10 over root 69. Does that look okay to everybody? Cassie, you okay with that? What part of that's bothering you? You're good? All right. Tangent, 3 pi over 2. So in other words, I want to know what's the fraction? What's opposite over adjacent?
It's 270, right?
So it's 270. Oh, wait, it's 270. Okay, wait. Why is that causing me to pause for a moment? 270 is here. So I'm not going to do a butterfly bow tie. 270 is not sticking out somewhere like 240 would. 270 is on an axis. So when I'm on an axis, I got to remember, let's see, tangent is y over x. And at this point right here, what are the y and the x at the 270 point?
0 and -1.
0 and -1. So x is 0 and y is -1. So when I build my fraction, I have -1 over 0, which is undefined. Is that okay with everybody? What?
The next one actually supposed to be 193 pi.
Okay. Dylan is already working ahead here. And he says, Miss Ford, are you serious? 193 pi over 4. That would be a huge angle, right? Oh, okay. Jason says, wait a second. A huge angle just means I have a lot of revolutions, right? So stop and think about it. When you get an angle, let's say I said something about, let's find the cosine of 420. All right, what would you do? 420, you'd say, 420, that's too big. You'd subtract 360, right? And work with the smaller angle. Well, this is exactly the same thing, only it's in radians, and it's bigger than that. It's a great big thing, but let's talk about it, because it's very manageable. We're finding the cosecant of 193 pi over 4. So here's what I'd like you to think about. What is 193 over 4? 48 1/4. So what I'm really finding is the cosecant of 48 1/4 pi. Would you agree with that? Now tell me about this. Tell me about 48 pi. I know it's huge, but really, what's 48 pi?
24.
It's 24 revolutions. So if I said I wanted to graph this, I would go around 24 times. Now why is it 24 revolutions? Because a revolution is 2 pi. So 48 pies would be 24 2 pies. Agreed? So what impact on my picture does that 48 have?
None.
None. So I'm just gonna forget it. Just like you subtracted the 360 out of that other problem, I'm gonna just get rid of 48 pi because it's nothing but spinning around 24 times. What I care about is after I've spun around 40 or 24 times, what's left?
1.5.
So all that's left is a fourth, right? And a fourth pi is 45. So this is asking me to find the cosecant of 45 degrees, which I can do. The cosecant of 45 degrees, cosecant is the reciprocal of sine, so this would be hypotenuse over opposite. So the answer is root 2 over 1 or just root 2. What, Dylan?
Isn't that a quarter and 90 though?
Pi is 180.
Oh, okay.
Let's try another one like that real quick since that gave us some confusion. Let's suppose we're going to find the tangent of 5,137 pi over 3. So Brenton says, dang, because that's a really big angle, right? We have no use for anything that's bigger than 1 revolution. So let's see what this is. 5137 divided by 3. Keep an eye on my arithmetic. Oh, did I write that right? I got 1,712 and a third. Jack's typing it in. Is that right, Jack? Okay. So, this is the same then as the tangent of 1712 and a third pi.
You don't look
Tell me about 1712 pi. That's divisible by 2, so it's 800 and some revolutions. Would you agree with that? So I don't even care about any of that. It's just, these are just extra revolutions. I'm going to find the tangent of 1/3 pi, which is the tangent of 60, which is root 3. See how easy that is?
Now, if it's not divisible by 2, does that mean it's going to be like landing on a different?
Exactly. So Brenton has a great question. Brenton said, what would happen if we did our mixed number? We did this thing right here, got this mixed number. And it worked out to be something like the tangent of 1713 and a third. What if that would happen? Exactly. That just means you can still take out 1712. That much is just revolutions. This would be the same as the tangent of 1 1/3 pi, which is the tangent of 4 pi over 3, which would be 240. Okay, so that's a great question. Thank you for bringing that up. When you get rid of stuff, just ignore stuff, what you get rid of has to be revolutions. Okay, so that's 2 pi's. You have to get rid of 2 pi's. If you have an odd number, one of those pi's has to stay, because you can't get rid of odd pi's, just even pi's. All right, okay, next. Cosine 2 pi over 3. All right, that's easy. 2 pi over 3 is what? 120. So I'm going to draw 120. It's going to be a butterfly bow tie because it's out here in a quadrant. How big is my reference angle? 60. So you've done this so many times, those numbers are automatic for you, or I hope they are. Notice I put a negative here because I'm not in quadrant 1, and anytime I'm not in quadrant 1, something's going to be negative. So the cosine would be -1/2. adjacent over hypotenuse. You okay? Look at number 5. We've already talked about this, I think. We want to find a positive and a negative coterminal angle for 2 pi over 5. Now we want a positive and a negative this time. How do we find coterminal angles? We add or subtract 2 pi. So a positive one will be found by adding 2 pi, and a negative one will be found by subtracting 2 pi. So I'll get my common denominator. What's my positive one going to be? 12 pi over 5. What's my negative one going to be? Negative 8 pi over 5. .1 radians is how many degrees? So pi over 180 equals 3.1 over x. Very, very good. Pi radians, 180 degrees. 3.1 radians, x degrees. So x pi equals, what's 180 times 3? I know, I'm at 3.1, I'm sorry. It's the question. So 558? So x equals 558 over 1. Solve the triangle. What does that mean? What am I doing if I'm solving a triangle?
Are you finding all the angles?
I'm finding everything I don't already know. Alright, let's finish this one, kids. I'm finding everything I don't already know. So I know that's 10, and that's 12, and that's a 90, and I need to find everything else. So, who can help me out here? This is going to be a calculator problem. Brenton?
Like the size C to B, isn't that 44?
Please excuse this interruption. This is just a reminder that all freshmen need to report to the auditorium, sophomores need to report to the cafeteria, and juniors need to report to the Walk Activity Center during flex. Once again, all freshmen, please report to the auditorium. Sophomores, please report to the cafeteria, and juniors, please report to the Walk Activity Center. Thank you.
All right, somebody remind me, we gotta finish this tomorrow. Okay, and I will see you tomorrow, and then you will, come with questions. Yes. Probably, let me see. Okay, so I marked that one wrong.
Yeah, but you
Then
gave
I
me
went
8.5.
back, I missed. Yes. So, yes. That's, I counted that 4 wrong, and they took off another half on top of that. So let me fix that right now.
Okay.
It's still a bad score, Michael.
Yeah, I know. I was just, those little things if you look at it.
Because we're not paying attention.
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8.5, so it's actually a 9.5.
All right, thank you.
Because there we go. Got it.
I just want to tell you that I'm going to be going half class Thursday. I'll be here for class Thursday, and then if we have class Thursday, well, I'll be gone Friday.
Okay.
Because I'm going